A scientist is working to create a new strain of peas. In a recent experiment, 428 of the peas had green pods and 152 had yellow pods. With a 95% confidence level test and the p-value critical value methods, test the claim that the proportion of yellow pods is equal to 1/4. In this area, do not interpret your final results yet. Our population proportion rho is equal to 1/4, so we're going to change that into the decimal 0.25, which allows for the opposite to be the not equal to symbol. Our null hypothesis and alternative hypothesis are the same respectively. With a confidence level of 0.95, our significance level alpha is 0.05. In order to test our claim, we need to know the total number of pods in this experiment. So we're going to need to add the green pods and yellow pods together to find n. The experiment includes 580 peas. We can now calculate our test statistic. With one prop z test, our p sub 0 is the 0.25, again relating to the null hypothesis. We have 152 yellow pods, which is the claim we are trying to test. We found that we had 580 peas in this study, and our proportion we are comparing this to is the alternative hypothesis of not equal to the null. This yields a test statistic of z equals 0.67 and a p-value of 0.5021. Since we're working with the not equal to sign, we need to find the critical value to be able to create our graph. The alpha of 0.05 will now need to be split between two regions, leaving us a 2.5% to the right, or a z of 0.025. Using INV norm, we have a critical value of 1.960. Creating our traditional graph, we can add our shaded regions and our two critical values. And we can also label our rejection and fail to rejection zones. Placing our test statistic on the graph between 0 and 1.960, we can see that we fall within the fail to rejection zone. A quick p-value graph will also have both tails shaded. Remember that the boundaries here are the test statistic and its opposite. And the total area covered is the total p-value found of 0.5021. Comparing our p-value to our significance level, we see that we're going to fail to reject the null hypothesis. Since we don't want to interpret the results yet, we want to look at how this will compare to using a confidence interval estimate for the same information. So if you use the confidence interval estimate for the true value of the population proportion of peas that have yellow pods, do you come to the same conclusion? Using one prop z int and a confidence level of 0.95, we come up with a confidence interval estimate of 0.226 to 0.298. So we can make our statement that we are 95% confident that the true value of the population proportion of peas with yellow pods is between 22.6 and 29.8%. Again, thinking about 25 or 0.25 as a percentage of 25%, and our statement, 25% falls between that range of our true population proportion. So since 0.25 is an element of the interval, we are going to fail to reject the null hypothesis. In this instance, both our confidence interval estimate that gave us the true value of the population proportion gave us the same conclusion as the p-value and critical value methods. Again, this is not always going to be the case, and if they had been different, you would want to go with the confidence interval estimate. When writing our interpretation of the claim, since our claim that the proportion of yellow pods is equal to 1/4 falls also in the null hypothesis, there is not enough evidence to warrant a rejection of the claim that the proportion of yellow pods is equal to 1/4.